Hi, hello guys, how are you? So after a long time, we are back. So without wasting any ado, let's try to get into the video. So in this video, I'm gonna talk about Gaussian distribution, or it is also called as normal distribution, which I personally prefer it as calling a normal distribution because of the very reason it is very simple to, pronounce it. So Gaussian distribution. It's for me, it's bit I know it's bit complicated, but anyways, like it all to the personal preference. Okay, so what is this Gaussian distribution? You hear whenever you come into this world of data science, whenever you talk about lot of machine learning, this whenever you come into this machine learning world, you hear this term a lot. Okay, so here I am to explain you in a simple language what is Gaussian distribution or normal distribution. So first things first, what is distribution? So okay, let me explain you. For instance, let's say you have a sample data, or let's say you have X and you have all these data points inside that. So whenever you see something, right? Can you observe any pattern in this? Like most of them are around 12 to 19, and most of the points are around uh 14 to 15, something like that. I just took this as a sample data, but most of the data will be like lying around some point. Okay, so there will be some middle point, middle ground, and there will be an initial point and last point, and most of the point will be lying towards this middle point. Okay, so whenever you plot this, like you'll get, if you get a bell curve, if you get this kind of bell curve, this it is said to be a normal distribution. It has set of few properties. I don't say that by just seeing the graph you would say that this is a Gaussian distribution or not. There are some rules that this point should follow. So if it is said to be a Gaussian distribution, or else like if you are given that you need to take this as a Gaussian distribution, then you can make use of the properties of it. So that's the main what that is called a distribution. Whenever you plot this, whenever you plot all your points in the data, uh, x1, x2, x3, x4, so on. Um, Sorry. So if you plot this and their corresponding probability of finding p of x1 and probability of p of x2. For instance, let's say this is the range, okay? 1, 2, 3, 4, 5, and let's take a different example. And 3, 4, 4.2, 4.5, 5, and 7. Okay, this is your data. Let's suppose this is your data. So most of the points are lying here. 4 to 5, there are 3 points, okay, and rest of them are like this. So probability of finding them between 4 to 5 is high. uh, for instance, let's say you wanna find out what is the probability of getting between 4 to 5. There are 3 points. 3 by how many are there? 1, 2, 3, 4, 5, 6. 3 by 6. It's like 1 by 2. And since 50 percentage of the probability is lying around 3 to 4 to 5. So that is that you are just plotting that, like the range of data points and their corresponding uh, probabilities. So whenever you plot, you'll get uh, something like this kind of graph. Okay. Uh, so let's assume that you have been given that uh, this is a normal distribution. So let's try to explain what are the properties of this Gaussian distribution. Most of the points, like they ri lie around the center of the data. Most of the points will lie in the center of the data. So that center of the data is also called as mean. Oh, sorry, mean, and it is represented by mu. Okay, that is one of the key term that you guys need to remember. It's like center point is called mean, means it is also called as average point. And the other one is like you need to know what is standard deviation. It is represented by sigma square. Uh, what does this standard deviation say? Standard deviation talks about the spread. Like uh, this is one graph, and this is one graph, mm, and this is one graph. You see the difference? All these are distributions of the data, but there is some expansion, right? There is some expansion. How are these things are expanded? There is a lot of expansion. So standard deviation talks about that. But if you have small standard deviation, it means that the spread of data is very less. So why I'm talking in such a layman language is like you need to understand what each term mean. Like without that, if you go sigma square, okay, now you will remember memorize the formulas, but later on you need to know the interpretation. That's the main motive that I have felt throughout my studies. Like it helped me. Okay, so coming to back to the topic, I told you what is mean and what is standard deviation, right? And the major property of this Gaussian distribution is it follows something called empirical rule. You guys need to remember this empirical rule. So whenever you plot this, oh, sorry, my bad. Let's choose something bright today. Okay, let's take this is our distribution. So what it says is this is mean, right? This is mean, and the standard deviation talks about how well is your data, how spread is your data. Mean plus one standard deviation goes here. Mean minus one standard deviation is goes in back of it. Mean minus two, mean minus three. So this kind of thing will be there. So what does this empirical rule says is so oh 68, 95 and 99.7. Okay, this is very standard. We need to remember 68, 95, 99.7. What 68 is within one standard deviation, in the sense let's choose this. In the sense like when you pass one standard deviation, mu plus 1 sigma, mu minus 1 sigma, this area, in the sense like how many points are there, 68% of your data lies in this within one standard deviation. Isn't that crazy? Yeah, it is. 68% of it's like more than it's like nearly three quarters of the data is being laid around that point. Okay, so this is very valid property that we need to remember. And the other one is like within two standard deviations. Let me choose something different. Within two standard deviation, you'll have 95% of your data. Like you hardly you'll find other one is like 5%. It means like this you can also consider them as outliers or something. Small point. Only 5% of the data. Only 5% together. And this is 2.5. This is 2.5. And three standard deviations, you will find 99.7% of the data. So that is one of the key property that you need to remember. It is called empirical rule. Okay, so this is mostly about like Gaussian distribution and one of the major property of our normal distribution. So this is up to the basic, and let's go one level beyond. And let's understand what is the mathematical intuition between this uh, uh, okay between this normal distribution. You have these points, right? In the um, in real world, in the sense like you'll have around this is like only 5 points. I'm just explaining you the concept, but in real world there will be 10,000 few observations or some million records maybe. So you can't go each one of them, right? You will have the assumption, either assumption or if that feature follows Gaussian distribution assumption, or you might have known the property, like they might given that this follows a Gaussian distribution. So how can you represent that? So you represent the probability of getting 15. For instance, let's say this is an Gaussian distribution. You wanna find the probability of getting 15. For instance, let's say you wanna get the probability of 15. You need something, right? You need a function to get the probability of getting 15. So there you go. That's the function. This is the function to uh, get the probability of getting x. If you put the values of standard deviation mu, in the sense like the mean of the values and standard deviation of these values, and 15, you'll get the probability of getting 15. So that is the formula of getting probability of random variable. Random variable is nothing but picking some value. Okay, it is the representation of 15. For instance, this is x. This is the random variable. Okay, now what is the mean? Mean is obvious, right? Mean is equal to sum of values divided by total number of values. For instance, let's say all these value summation and number of values 1, 2, 3, 4, 5 gives you mean. Standard deviation formula is summation of every value minus mean whole square divided by n gives you standard deviation. It means like it will tell you how spread is the data. Now this is the medium level. Now we are going one step advanced. So we're going to derive these two things, mean and standard deviation. At max, I'll try to go just stop with mean, because like I think it will become too much, but I'll try my level best to cover I'll at least tell you how to do standard deviation as well. So now there's another concept called maximum likelihood function. So what it does is it will try to find out the parameters. So the main motive of this maximum likelihood function is like it will find the parameters. All these are parameters, right? It will try to find the parameters where most of the data is like you can find most of the data. It will give you where does the most of the data lie and what are their parameters. If you put these parameters, you will get most of the data. So that's the motive of this, and you use this method in lot of ways, a lot of derivations. And what you do is uh, first things first, what is maximum likelihood? Whenever uh, this is corresponding to one point, right? There will be lot of points, 1, 2, 3, 4, 5, all these points. You will multiply the probabilities of all of them, 1 into 2 into 3 into 4 into 5 probabilities, not the points. Okay, so you'll get the maximum value here. So you did the multiplication of this term remains same, and this is like each point 1 point, 2 point, 3 point, and now you do logarithms on both sides. The reason of doing logarithm is like it will make the calculation simple. You know, whenever you do the multiplication, it's like little bit of complex. If somewhere or other, like if we do some wrong calculation, for instance, let's say this is 0, you did some wrong calculation, it became 0, all of them become 0. So it is like pathetic, right? That is one thing. And other thing is like, which I did my research and I found out that your equation might be in the real world, it might be look like this. By applying log, it will convert your function into a proper concave. So that's the main other major advantage of applying log. Okay, so you apply log on both sides. The property of log is log of AB is equal to log A plus log B. So this is one of the property that you need to remember. So multiplication became summation because of the very reason, by applying log on both sides. And as I said, multiplication became plus on both sides. Now what you do is, now we want to find uh, let's suppose mean. Okay, you take the derivation of both sides. The reason of taking derivation of both sides is the function log function might it will look like this generally. Okay, so whenever you do derivation, the derivation is nothing but slope. Okay, d by dx of some function, in the sense function, what is the change of function with respect to x, right? So what does it tell? It talks about steep steep is the, like the curve. And that is one thing that it says. And the other thing it says the direction as well. If it is positive, it means like it is going up. It might be vice versa. But if it is zero, it means the line, it's like it's straight, it's like the angle is 180 degrees. That's what it says. So you need to find out the maximum number of points that are lying in this function, right? It means in this function, where is the maximum point? That's your goal. So this is the maximum point, right? This is the point that you need to find out. Your goal is to find here. So if you find here, what is that? It's the mean, right? That is mean. That is the one that you want to get it. So you derive it with respect to uh, with respect to uh, L of x with respect to mu at mu. When you do the derivation, let me erase this. Guys, please let me know how is my teaching. Mm, and I'll try to record more of them if you guys like it. Okay, so that's the derivation. So there is no term of mu here. So what's the point? Dy dx of 2. What's the derivation? 0, right? So this term becomes 0. This term becomes 0 is equal to 0 plus. And next one. Okay, let me do the smart work. Nice. So you want to do the derivation of this part. Derivation is nothing but d by dx of log x is 1 by x. Okay, so d by dx of log of something. So d by, no, sorry. So that would be x. Let's consider this as x, and log x would be e power, no, say xi minus mu whole square divided by 2 sigma square. And now you need to, as you consider this as an x, and you'll do the derivation for this on top. So derivation of d by dx of e power x is equal to e power x. So you consider this term as an x, and due to the derivation you'll get the same part, right? And now you do the derivation of this, because like you consider this as an x. So dy dx of minus xi minus mu whole square divided by 2 sigma square. Okay, now both these terms will get cancelled. Now you are left out with only this term mu, sorry. So minus 2 sigma square to xi minus mu whole square. Okay, now as I was telling, okay, I cleared the diagram, right? We are doing the derivation and we are trying to find this point. So what's the property of the stop point? Equal to 0. The derivation will be 0, right? So you are equating with 0. Now let's do the derivation. Oh, sorry, forgot the summation, which is one of the important points now. 2 sigma square, and the derivation of this would be, let's consider this an x. 2 into xi minus mu, and due to the derivation of the inside part, which will be 1. Okay, now the successful derivation is completed, but now this term goes to get cancelled, and this sigma square goes the other side, which becomes 0. Then we'll be left out with this part. Okay, well, we came to the last. Now as you can see, summation of something, there is no x part, right? This is a constant, mu is a constant, right? So summation of 1 into mu, in the sense you are adding 1 n times, so you'll get this is equal to 1 n xi minus, you're adding 1 plus 1 plus 1 plus so on n times, so you'll get n into mu equal to 0. So this part will go here, n into mu is equal to summation of all the points 1 to n, and mu is equal to 1 to n xi by n. There you go. Your mean is equal to summation of all the points divided by number of points. Ta-da! So that's how you derive for mu. And now if you want to do the derivation for uh, standard deviation, you can also do it the same thing. So this part is there, right? Copy, paste. So this part was there, right? Now you will do the derivation with respect to standard deviation. If you do the uh, derivation with respect to standard deviation and make it equal to 0, in the sense like this is a function of, and you want to find this point, so that's how equal to 0, then it will become you'll find the standard deviation. So I hope you guys liked it, and okay, let me do the derivation for this as well. And so when you do the derivation for this, you to do it Oh, sorry guys. I was just trying to figure out why is it just a little bit wrong. Anyways, like we made it to zero, right? There is no mean here, so we made it to zero, so we didn't had any trouble. Now we'll get some trouble. That's the reason I found out like something was wrong. Now I just cross-checked my equations. Now it is looking good. So tell me this: 1 by x square. How can you write this? You can also write this x power minus 2 as well, right? You can also write it like that. So right here, now the term is 1 by root x. Root x is nothing but 1 by 2. 1 by x power 1 by 2. Now you can write it as minus x power 1 by 2. That's how you write here log of 2 pi square minus 1 by 2. Okay. Same here. Now this part goes before. You can write like this. So function will become to log e equal to 0 in the derivation part. Okay. Now if you do the derivation, and this part will go before. Now there's a multiplication here, right? You can convert that into addition. The reason why I'm doing all this is to make the calculation simpler later. Now, see here, there is nothing but you're adding it n times. What it comes, so will convert into n minus n pi 2 log 2 pi. Same here, minus n by 2 log sigma square plus this term. Okay, so for ease of convenience I'm not writing it again. So whenever you derive it with some constant. There is no sigma square, so it will become 0. 0 plus minus n by 2 into log derivation of log x is 1 by x, right? 1 by sigma square plus this part. Now if you do the derivation for this, so this part comes before, this part is constant, right? By 2 is also constant. And so sigma summation of no summation derivation of 1 by sigma square is equal to n by 2 sigma square x minus mu whole square, and derivation of this 1 by x power minus 1. So x power minus 1 into x power minus 2, right? So it will become minus 1 into sigma square whole square equal to 0. It's multiplication, guys. Minus mu by sigma power 4 equal to 0. When you do the LCM, your term becomes sorry, forgot 2 here. Yeah, the 2 is there, right? This 2 came here. So whenever you do the LCM, now xi minus mu whole square equal to 0. So the entire term 2 sigma square will go outside that side. It became 0. Now n sigma square is equal to summation of I is equal to 1 to n xi minus mu whole square. Now n will go here. Now standard deviation is equal to summation of I is equal to 1 xi minus mu whole square divided by n. So that's how you derive standard deviation. I told you, right? It's a little bit big, but don't worry. In some examinations, you need these derivations, and also you need to know the concept, like why are we doing this? Like, why are we doing maximum likelihood? I told you the concept, right? You'll find nowhere. Like, I did a lot of research. I did ChatGPT. I'll be honest with you. I went to ChatGPT and I asked it again and again, again and again. What are the? I want to know what is the like without interpretation. I thought it's nothing. So I went to a lot of YouTube channels. I didn't find this kind of content. Why are we doing derivation? No one tells why are we doing derivation. Everyone goes and says, okay, we do the derivation and you made it to equal to 0. Why? Then I did all of my research. That's the reason I kept it like layman language. But you might see all this equation complex, but if you know the derivation, you'll understand things better. So I hope you guys liked it. I think it was a lot of long video, but that's okay. You will now you got to know about what is Gaussian distribution and how we derive the formulas, and what is the Gaussian equation, P of t, P of a random variable, what is the equation, how you do the maximum likelihood function, maximum likelihood equation, and how you derive for the mean and standard deviation. In the same way, there will be a lot of distributions out there, Poisson distribution, Bernoulli distribution, and once if you have that function, you can derive for the mean and standard deviation using the maximum likelihood. I hope you guys liked it very much, and I completely appreciate if you guys are watching till the end. Please do subscribe for my channel ML Made Easy. And a small secret, all these images is generated through DALI E through GPT-4. Okay, this you make use of this GPT, man. I hope you guys liked it. Thank you. See you on the next video, guys.